All right, guys, are there any questions on the homework assignments? What we're looking at today is synthetic division. Synthetic division. Now, synthetic division is going to be a little bit different than long division, and for the most part, most students find it easier to do synthetic division than it is to do long division. Now, when we do synthetic division, there's a few things that we need to do. The first main step is that we need to solve the divisor for the variable. So what that means is we'll take m minus 3 and set it equal to 0 and find the value of m. So we would add 3 to both sides and get that m is equal to 3. Any questions on this so far? Now the next thing we're going to do is we're going to actually set up the problem. In setting up the problem, we're going to have a cubby hole and a line. Now the value that we found for m will go in the cubby hole. And now the numbers, the coefficients in front of every variable that we're dividing by will go along the top, and we need each variable. So we start off with m cubed, and the number in front of m cubed is 1. The number in front of m squared is negative 13. The number in front of m is, and then we have 18. If there is a variable missing in what we're dividing, we need to put it in as 0. Any questions on this so far? Okay. Now that we're going to actually start doing synthetic division, our first step is to bring down the first number. Now we're going to multiply it by 3. I'm going to erase this here. So we'll have 3 times 1, which is, and we'll put it under the second number. And then we will add straight down. Negative 13 plus 3 is? And then we multiply by 3 again. So 3 times negative 10 is negative 30. And we put it under our next number. Then we add straight down, which would give us. And then what do? Multiply that by 3. 3 times negative 6 is? Add straight down, and we get 0. So we're almost finished with synthetic division. We just have to put the variables back. Here, since we're dividing by a binomial, 2 terms, the last number will be the remainder. The number after it will be our constant term. The number after that will be the term with x, and the one after that is the term with x squared. So our final answer for this here is x squared. And that's it. Any questions on this here? We ready to look at the next one? So the first thing we need to do is to solve for what? V. Minus 4. So V is now we can set up the synthetic division. So we'll have our cubby hole in line. The number that goes into the cubby hole would be -4. The numbers that go across the top would be, so 8, 32. We would not have 5, 0. Because we have the fifth power is 8, fourth power is 32, so third would be 0, second would be 0, first is 5, and then we would have 20. So we need to make sure we do have each and every single one. Because our powers are? Yeah. Because we would add 0v cubed and 0v squared in so that we have every variable going from 5 to 0. Our next thing would be to do is to drop the 8. Then what would our next step be? Yep, -4 times 8. And then we would add and get 0. 4 times 0 is 0 plus 0 is -4 times 0 is 0 plus 0 is 0 times 0, -4 times 0 is 5 plus 0 is, then we would do -20, and -20 plus 20 is 0. Not quite, because so let's put it back in. So 0 would be the remainder. Last number is always the remainder, and I box it. The number in front of it would be our constant term, because we could say that this is x to the 0, which is just 1. Then this would be x squared, x cubed, and x to the, so our answer is 8x to the 4th plus 5. Because the x cubed term is 0, x squared is 0, and x is 0, so this is all we have left. Any questions on this here? Are we ready for the next one? Yep. So, first thing we need to do is solve for the value of x. So what would we do first? Well, we'd subtract 1, and then we would exactly have to divide both sides by, add 1, thank you. Add 1 to both sides and then divide by 3, which is telling me x is equal to 1/3. Now, unfortunately, because we divided the one side by 3, we'll have to divide the polynomial by 3 as well to get this to work out right. And the reason that this is that we're going to have to do this is mainly because if we looked at this, say, with long division, we're not going to look at the whole thing, because 3x cubed minus 4x squared, we have the rest of it, and we're dividing it by 3x minus 1, yes? What times 3x is 3x squared? It'd just be x squared, yes? Okay, because it'd just be 1x squared would be our first term. Now, we do see that. Now, if we set up the long division as we have it right now, and I'll set it up over here, is we would have 1/3 inside the box, yes? And going across the top, we would have 3, -4, -17, and 6. And what would be our first step to drop the... Well, what do we know the first term is when we did the synthetic or long division for the first step? It was 1x squared, yes? Because if we solved it this way, 1/3 times 3 is 1. This would give us -3. 1/3 times -3 is -1. -18, which would give us -6 and 0. But does this match up with our x squared? No, we have 3. So what we actually have to do is we have to divide this entire thing by 3 to get to the right answer. 3x cubed divided by 3 is x cubed minus, well, x squared minus 17/3 x plus 2. Now that we have it this way, we can actually do the synthetic division. So we would have 1/3 here, and across the top we would have 1, -4/3, -17/3, and 2. So our first step would be to drop the 1. 1/3 times 1 is 1/3. What is -4/3 plus 1/3? It would be -1. And 1/3 times -6 is 1. So this here would be the remainder. 6 would be our constant. So it would be x squared minus x minus 6. Now we could have solved it the other way, but we would have to have divided by 3 at the end. We need to divide by 3 at some point to get to the correct answer. Questions on this here? So having a number in front of the variable in our divisor causes us having to divide on both. It makes it a little more challenging. But any questions on this here? How do we feel about synthetic division? We feel good about this here? Do we need to see another example of having a divisor as a binomial? So these don't look good, don't bad. Not too bad. We feel good with this one here. I think I missed one. This one. Let's look at this one. Because it is not a binomial, it's now a trinomial. Now with a trinomial, we want to get x squared by itself. So we want to move the other two over. So we can do that by adding x and adding 4. We have that x squared is equal to x plus 4. Okay, put a different color. A little bit bigger cubby hole. Now the number in front of x is, and the other number is 4. So with a trinomial we have two numbers. Yes? 1 and 4. So it's two separate numbers. Now the numbers going across the top would be 2, 1, negative 15, negative 2, negative 2, 10, and negative 24. Then we would have our line, yes? And we would have our line. We need two lines because we have a trinomial that we're dividing by. Now, the next part of our synthetic division was to drop the number, yes? 2 comes all the way down. 1 goes down 1. Now we're going to multiply. So we're going to do 1 times our 2. Everything's going to be multiplied by the bottom number, all the way at the bottom. So 1 times 2 is 2. Where do you think we'll place that? Under the 1. Then we'll do 4 times 2, which is 8. Where do you think we place the 8? Yes. 8 is going to go under the 15. So the first number will go right above the second line. When we multiply with the second number, the 4, it's going to go right above the first line. Then we add straight down. 2 plus 1 is? Negative 15 plus 8 is? Now we do it again. Yep, so 1 times 3 would give us 3, and we put it under the negative 7. We do 4 times 3, which is? And put it under the negative 2. We add straight down. Negative 7 plus 3 is? Negative 4. Negative 2 plus 12 is? Now we do it again, but now we're multiplying with? So we do 1 times negative 4 is? 4 times negative 4 is? Negative 16. Add straight down. 10 plus negative 4 is? 10 plus negative 16 is? Now we're going to multiply it with 6. 1 times 6 is? 4 times 6 is? Negative 6 plus 6 is? Negative 24 plus 24 is? Now, at this point, we're done. Even though they don't line up at the end, and they are both zeros, so that kind of helps, but if there was a remainder, we would still have numbers here. But if I were to continue the multiplication, see if I can get a highlighter today. Nope. Our first multiplication would go here, yes? With the 1, but where would the 1 with the 4 go? Well, we don't have any place for it. So when we have a trinomial as the divisor, these last two numbers are the remainder. These last two numbers are going to be the remainder. The first one here is going to be our constant, and this is going to be our remainder with x. Because again, it is a trinomial, it is a degree 2. So we'll have one less than it. Over here, we have 6 as our constant term. -4 is our term with x. 3 is our term with x squared. And 2 is our term with x to the third. So I show you this to show you that it is possible to do this with non-binomial divisors, dividing by something that's not a binomial. But it does get a little bit tricky. Questions on this here? So it would be 2x cubed plus 3x squared minus 4x plus 6. Any questions on this here? There is something interesting with it. Because what was the degree of what we were dividing by? And our divisor was 2. What's the degree of what we finished with? Because 5 minus 2 is? Let's see if that's... So here, the degree that we started out with was, what we were dividing by it with is, and our new one is. So each time we divide, we're decreasing the power by. And that really is the big goal with division. And we'll get into this tomorrow and really start delving into this more tomorrow. But have we come across, because tomorrow we're actually starting solving, but have we covered anything about actually solving a fifth degree polynomial? But what do we do know how to solve? Because if it's degree 2, it's a quad. Do we know a lot of ways to solve a quadratic? So if I can take this from a degree 5 back down to a degree 2, we have multiple ways to solve it. That's why this is important, because we can reduce the power one at a time and get back to something that we can. Now the last thing we're going to look at is this here. Use synthetic division to evaluate this here when x is -4. Okay, so if we were to evaluate this here, like we did before, we would take f of -4, and we'd plug it in for every x value, yes? We'd have 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. And we could plug that in. And if we plugged it in, what would we get? I think it's -255.
I got -359.
I might have. It might be -359. Yep. -359. Yep. Ah, yes. I put -13 instead of +13. So we get 359. Let's do this with synthetic division. Now, they already gave us -4 because they already solved it for x We don't have to do anything there. Now we can put the coefficients across the top. So we would have 5, -1, 13, and 29. First step would be to bring down the -4 times 5 is, add straight down. -1 plus 20 is -21. -21 times -4 would be 84. The negative and negative would make a positive. And 4 times 21 would be 84. Then we would add straight down, which would be 97. Now we can do 97 times -4. Well, we'll get a negative number. 4 times 7 is 8. Carry the 2. And then we'd have, and then lastly we would add straight down. Or sorry, yes, that'd make more sense. I think I forgot to add the 2, -388. And this would give us and that there would be our remainder, yes? What did we evaluate this at? What did we evaluate this at a minute ago? Those are going to be the same. So the remainder ends up being the exact same as if we plugged it in for x. So what that tells me really is that if I have a remainder of 0, it divides evenly, yes? So if I plug the number in for x, it would come out as what? 0. So if we plug in a number and we get 0, it is a solution. It means it's divisible. And we can use this to evaluate. So let's do this again with 5. Or for this one here, evaluating this function for 5. And this time we're just going to use synthetic division. So our coefficients would be 4, -10, and -21. What would we do first? Drop the 4 down and do 5 times 4, which is 20. Then we'll add straight down. -10 plus 20 is 10. 5 times 10 is 50. And -21 plus 50 is positive 29. So when we evaluate this function using synthetic division, the value would be 29. Any questions on this here? Do we need to see another example of one of these? And that's it. We do have an assignment. Homework is on page 187. Problems. Three. Thought it might be a little bit easier to read it if it wasn't slanted.